Take two. So yes, so the point I wanted to make here was that basically this was for an open science symposium we gave at OHBM. There are a lot of aspects of open science that I am really passionate about, and I would be happy to either touch on during the talk or talk about afterwards. If you have any questions, feel free to stop me. But to really kind of get a handle on what we want when we talk about open publishing, I think it's important to kind of review what the situation looks like today. So what does it mean today when we say we want to publish something? So the first piece is that you and your colleagues will have designed a study, collected data, analyzed the results, and written a paper, which sounds so easy when it's one sentence, but we all know is science, right? This is everything we do. So now that you've done the easy part of doing science, what does it mean when you go and want to publish? First, you'll need to send the paper to a journal. So you need to decide what journal you're going to send it to. Maybe you know the editors, maybe you've previously sent to that journal. Then you have to wait on whoever the assigned editor is to find suitable reviewers for your particular paper. Then you'll need to wait on those reviewers to provide revisions. And as we know, in months like the summer, it can be a little bit longer. So this is a bit of a process here in itself. Then you'll need to address the revisions and resubmit. And having gone through this a few times now, I think we can all agree that there's a little bit of iteration between addressing the revisions, getting new revisions, addressing the revisions. This can take a couple cycles. And finally, you'll correct the final proof and publish. So these are quite a few steps. And what very smart folks have already realized looking at this is we could make it much, much simpler. And one way we could make it much, much simpler is just to send the paper and publish. I'm going to come on to that later. But this idea of just being able to send off the paper and have something that you can reference, that you can cite, that folks can look at right away is really kind of what preprinting is today. So there are lots of reasons to preprint. Some of the original arguments were around, it's good to get the information out there, but a lot of folks, including here Nico Krikos-Korte, has a really lovely blog post where he says, no, there are a lot of selfish reasons to preprint. He even does a breakdown timeline of the optimal time to preprint to get more citations for your paper, right? Because there's a citation advantage for preprints. So there's lots and lots of reasons to preprint. As an individual scientist, and for the community, there are lots of reasons to preprint. So, this was a quote from a recent eLife review about, reviewing preprints, and Jeff Leake says, if you want to be 1 year behind, don't read bioRxiv. And this can extend to any of the major preprint servers now. So don't read arXiv, don't read bioRxiv, don't read scIRxiv, whatever your field is using. People are publishing preprints there quickly enough that to keep up with information, it's really, really helpful if you're reading preprints yourself. And you can get the citation advantage from posting them. So it seems like there are a lot of really good things happening with preprints. But this is just one way that we can kind of update this timeline that I showed you of what publishing looks like today. So let's step back and look at that timeline again. And before I do that, I want to point out to you that what we've talked about with preprints is really creating science that's findable and accessible. So what that means is the preprints are available online. You know where to find them under some preprint server by some author name, and they're also accessible. You don't have to worry about paywalls. You don't have to worry about particular certifications. You can just get to them right away. And one thing that may be familiar about the terms findable and accessible if you've been around open science a little bit, and if you haven't, I'm really excited to show this to you, is this idea of FAIR. So FAIR is an acronym used a lot in open science, and the first two letters are literally findable and accessible. The next two letters are interoperable and reusable, and these four have kind of been put out as the characteristics of open objects, research objects, so open mostly data sets and code at this point, that we want to make sure that when we release these things, not only are they findable, so they have an address, they have something permanent, not only are they accessible, you don't have to worry about paywalls, but ideally they're also interoperable, which means that if I get your code and someone else's code, I can make them work together either by doing a language translation or by just combining the modules. It doesn't come as a binary file where I'm just stuck with exactly what you gave me and I can't make any changes. And they're also reusable. So it's not a run one time on this data and never again. It's something where I could take your code or your data set and run it on my data or for my own analyses and see what happens. So this makes a lot of sense in the context of data and code. This is where people have talked about it the most, making things fair. But like I said, so open publishing is creating this findable and accessible science. But what if we wanted to get the whole circle, the whole acronym? What would it take to get to interoperable and reusable publishing? And so with that in mind, let's go back to this timeline. So we've done science as a whole. And so now this publishing timeline has us sending the paper, waiting on the editor, waiting on the reviewers, addressing the revisions, and doing that a couple times, correcting the final proof, and then publishing. But if you really narrow in on this word and publishing, it's a little weird. It feels a little recursive, right? Because I told you this whole timeline is publishing today. And then I tell you at the very end, now you can publish. Now that you've done all these things, you finally get to and publishing. So I think we should really drill down on what it means to publish. What does it mean when we say we're publishing something? So in the context of preprints, which I talked about, it's really just making it findable. It's putting it out there. It might be what we consider posting it. But if we think about what we want from publishing, what we want from publishing is to create a body of literature that we can really build on. And so this is really illustrated beautifully in one of my favorite pieces from the machine learning journal Distill about research debt. And the idea here is what we're doing when we're publishing most of the time is not that different from really just posting things. We're just creating new pieces of paper. And this makes a lot of sense because the process that we originally worked with was designed basically in the 1700s, right? It was designed when all we had were pieces of paper that we could mail around, that we could stick on desks, and we really haven't changed since then. So now when we think about publishing, we're still thinking about creating static sheets of paper. And when you build on your colleagues' research, what ends up happening is you can think about literally just stacking the sheets of paper on one another. You can't actually, most of the time, pull from your colleagues' figure generating tools and use it on your own manuscript. You can't actually pull all of their code and run it on your own data set and see how it generalizes, right? These are things we really love for open publishing, but right now the system is really geared to just create what Alan Carter referred to as a mountain of research debt, because you just have these manuscripts that you can imagine stacking on top of one another like a mountain, and then we as academics spend all our time trying to climb it so we can lay another paper on top, which is one way to do science, but I think we could do something else. And the other reason I think this is there are a lot of really smart people who've argued this very beautifully. So this quote is just one of my favorites. It's by Buchelt and Donahoe, and they say, an article about computational science in a scientific publication is not the scholarship itself. It is merely the advertising of the scholarship. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures. So here what they're really saying is when we write a manuscript, when we just release a PDF, you're not releasing the science that you did. You're releasing an advertisement of the science that you did, which is great. We need those, but also we need to be able to have the actual science you did so that we can build upon it, that your colleagues can use it, that you can extend and replicate it in ways that help us grow as a field. So the question that I think is pretty obvious to me every day right now is how do we get to fair publishing in today's landscape? Because we're not there. And there's a lot of work to be done to get us there. But I think that we can look at a few examples, and I in particular am really motivated by some of the examples I'll show here to think about how we could get there. And I'd also love you guys to shout out if you have any ideas as well, because I think this is a really hard problem. But I think the people who are probably the closest right now is Jupyter. the Jupyter community. So you may be familiar with Jupyter if you've ever played with Jupyter notebooks or IPython notebooks. If you haven't, they're amazing. I'll show you a picture in just a little bit. You'll love them. But basically, they're a way to interleave code and text and data all in one document. And so Jupyter is most well known for this, but they've done quite a few things. And the reason they can do so many things is because what Jupyter really is a community of people who've developed an ecosystem of open tools and standards for interactive computing. And I think this point on the community is really important. I think, as Nicola pointed out, this is something I'm really passionate about. So this is just like a very small subsection of the people who are involved. They're constantly looking for new people to be involved. And one thing that's really important to note is I think there are maybe 2 people who are at the same institution on this whole slide. Like, this is a very widely distributed network of collaborators. It's all done online. It's all remotely. It's all really interested in bringing new people in. And because of that, they can do really cool things. So their goal in developing these tools is to create things that are language agnostic and modular. And that will empower people to use other open tools. So Jupyter Notebooks, maybe you've first heard of them for Python, but they're not for Python. You can use them for Octave. If you set it up really well, you can use them for MATLAB. You can use them for R. You can use them for Julia. You can use them for almost any language. It's really just kind of a framework to allow you to have these things, because their philosophy is that we're not trying to build a one-stop solution. We're trying to build something that people can bring into their own workflows and use it to make their work better. So I think this sounds great, right? Like, this sounds amazing. But what does that actually translate to? What is this philosophy? What does this community create? And the first thing is Jupyter Notebooks. So these are kind of the, like, when you first hear about Jupyter, this is probably where you start, for good reason. They're wonderful and amazing. But what you can see here, so this is just an example they give of exploring the Lorenz system. So here you can see that they've got some explanatory text, the equations, the actual code, and then it generates an interactive figure. So what you can do is you can actually go and modify all these parameters yourself and see how it impacts the system, which is really, really helpful if you're trying to learn this system and to understand different aspects of it, right? So this seems really cool. Very, very big fan of this. But what if we take that a step further? So what if we say, okay, Jupyter Notebooks seem amazing. What if I want to use them in an educational setting? What if I want to teach with them in my course? This is something a lot of people want to do because it makes a lot of sense to interleave these pieces in a course. And so Chris Holdgraf has actually really recently spearheaded the development of Jupyter Book, which takes a collection of Jupyter Notebooks, translates them into a website, and the original goal was that it's like a textbook for your course. So you can go through, you can see the code, you can see the outputs. Again, you see explanatory text and equations, and you can actually show or hide the code. You can make it so that students can go through and really kind of dig into all these pieces, which is amazing. But what's so cool is then a subsection of the community was also like, what would be great is if we could make these things that live on the web interactive. So there's also this service run by the Jupyter community called Binder. So you can access it at mybinder.org is the original site, although there are Binder hubs popping up everywhere these days, which is wonderful. And so what you can do is you can actually give it the path to any Jupyter notebook that lives on the web. And if it's set up in a repository where the inputs are described in a standardized way, so if you have like a requirements file and you list all the requirements, then you can just run that Jupyter notebook on the web. And so they use that in Jupyter Book to make it so that each code block that you show to students, you can click on it, make it interactive, change it around, and change all the output in their textbook, which is a really nice way to kind of learn these things. So we've taken that in a slightly different angle recently, actually. So Matthew, who's on this call, Aga and Nicola, who are here, and I, among many, many other people, too many to name, but at least on this slide, have been working on NeuroLibre, which is saying this is an amazing idea, but if we think beyond education, just thinking about publishing generally, it would be really useful to have this way where we can interleave code, explanatory text, the outputting figures, and make it so that our publications, when we create them, have all these pieces. So not only will they show up online and not be behind a paywall, now we'll also have it so that you can actually access the code to build on it, and you can reuse that code because you can see it for your own analyses from these papers. So NeuroLibre notebooks is the idea right now, but I think this is something we're really actively thinking about. And then the final piece, because I showed this at OHBM, that I do want to point out because I'm really excited about it, is Aperture, where the goal is to create a open source publishing platform where you can host objects that are non-traditional, like publishing objects. So, you know, traditionally we just publish PDFs, but now if we're creating NeuroLibre notebooks, if we're moving to fair publishing, we can see not only we might be interested in NeuroLibre notebooks, we also might be interested in things like open code and open data and software reviews, and having all of these in a journal where you can see really what science is being done today and have it easily accessible and workable would be something that I think would really move us to the next, I would argue, phase of publishing, where we start to excavate the mountain and carve little paths through and help eliminate some of our research debt that we've built up for a little while now. So that's, with that, I really want to thank everyone that I worked with on this. Too many folks to name, but some of them are here, so thank you in particular to all of you. I have a few take-home ideas, and I'd love to talk about either, you know, paths that you see that are productive moving forward, concerns that you have about this, or anything open science related generally.
So thank you, Elizabeth. I really appreciate that, you know, we get more people in the lab familiarized with these concepts. And when we asked you to come and present, we said keep it short. That way we can, you know, discuss and see what of this might actually be of relevance to our group. And maybe one thing that can just kick some of these discussions off is, would you care to tell us about some examples, like actual, you know, supplementary materials or tutorials, and what they have in them, maybe some of your own work or something that you're aware of that would be a nice demo?
Yeah, so I can show, okay, so I'm going to stop sharing the screen and then I'll come back, Matthew and Tommy. But I can show actually, so Matthew has a notebook.
How many of you have seen Matthew's notebook, by the way? It's not that many, even.
Okay, so there's this NeuroLibre site. So right now it's at neurolibre.conp.ca. And where we have right now is a collection of notebooks that we've sort of tested this idea on. So I'll just show the quantitative T1 mapping.
Maybe you can also go through yours. I think both are fine, just as examples.
Yeah. So this is one that Matthew wrote. So what's nice about this is you can actually see, I can click like interact inline, and it should assign a kernel out. So we can see that, oh, it's not on this page. We can see his explanatory text and his figures, and then, yeah, here we go. So you can go through and actually see some of these differences for yourself. So this one's a Plotly image, but if we show the code here, so he's got a really clean thing, and then we can actually go through and see, well, how did you generate this image? What would I need to do and what would I need to change to make this image for my own work? So here he's separated out into the simulation and the plot, which is really nice because then I can say, well, I love your plot, but I want to simulate something slightly different, or vice versa. So it's a really beautiful sort of format to go through and just to say, okay, how can I interact with these things? And then what I could do is to go launch a binder. So this is that site I showed you where it was my binder. This is a similar thing, and so you can see it's launching the server for it, and in a minute it'll load and it'll be the notebook itself with all of the code and the data embedded so that we can just go through and interact with it. It doesn't take too long, but you do have to wait a little bit.
But this is what we're working on. So basically, before this concept can really become mainstream, we're working on making Binder run on the Compute Canada infrastructure.
Yeah.
and hopefully we can cut down on this launch time. It's been our biggest hurdle for a while.
But it's not, if it's for your own work and you can launch it in one place and then come back to it, like it doesn't take more than usually like 2 to 3 minutes max. It's just in a presentation. It's a little odd to wait for it the whole time. But that's okay. So I'll come back to it too.
So are those notebooks based on Jupyter technology?
Yes, exactly. So these are all written in Jupyter notebooks, converted to Jupyter Book, and then displayed here.
Because on the NeuroPoly website, it doesn't, so it says, powered by Binder, resources provided by CNPC. Maybe it would be nice to add also Jupyter as a...
Yeah, so Binder is part of Jupyter, but absolutely. I think it's good to, no, but it's a good point. It's like Jupyter is such a big ecosystem that it's really nice to point out the specific
And
points
it could
to.
just be in the text, interactive notebooks currently. I think it says interactive notebooks. It could be interactive Jupyter.
Yeah,
And
that would be perfect. So this is one I did, similar sort of thing. So here I'm displaying the code by default because this was for a programming tutorial I gave on introductions to machine learning.